All right, how's it going? Slip. And today we're going to continue inlining, I guess. All right. So let me just turn down the volume. And I think you already saw it in the screen. All right, but I'm just going to show you a little bit of what's behind the scenes. We have a string here, right? So it's just a Q string, regular old Q string, and we are passing it through the new parser, setting the f flag to 0. That makes it so you basically tell the parser this is not a file, this is a string, right? And so you just pass the code as a string, and it will pass it as it would pass the contents of a file, right? So it's same procedure, right? Nothing changes. The only difference is uh, the call to open up the file is not made. So that's basically what. It's just one conditional. But anyhow, and this is the function we are inlining, okay? And we're handling multiple cases in here, okay? So this is the most basic one. Let me show you that first. So this would be when you inline a function that is a single line that is doing no assignments onto the variable that it's working with itself. It's making no modifications to the arguments, right? So this can be just inlined as just in place without creating a new scope. So let's see what that looks like. And as you can see, well, here's our program tree, right? So this is the tree for the string that we initially passed. So this code right here. Here's our tree for that, and here is that tree, but flattened and with the inlining applied. And as you can see, x equals test function has been converted into just the call itself. So that's fine. That works. We do have to take care of the parentheses now that I just realized this. Silly me. But it's actually not very difficult. We can just go into hacks inline.pm, and it's find args, if I'm not mistaken. Yep. So find args, and what I have to do here is just take the parents off the top, so to speak. Okay. So let's do that. Okay. We're just going to do this globally, so to speak. Right. So globally, as far as the subroutine is concerned. And I guess I can just make this a state. Why not? I'm not going to. I don't think I'm going to be using this regex outside of this, but if I do, then I can just move it elsewhere. For now, let me just check something real quick. Okay, all right. So my microphone is plugged in. Anyhow, what I want is, I suppose, any number of spaces and parents at the beginning of string, right? So this kind of construction. I want this, or any number of spaces, closing parents, and any number of spaces. So yeah, I kind of have to use that greedy thing there. Maybe I wouldn't have to, but yeah, whatever. And end of string, obviously. And we just apply this globally. As if it... Now I don't remember what the m does here at the end. I think it's for converting this thing into end of line, or a start of line, or start of string. I think it's about that. I'm not going to need it here, so I'm just going to leave it at that. And I shouldn't need these because there will be no new lines in here. I'm pretty sure there wouldn't be, but just because. Okay, so let's run that again, and it did not work. Oh, because I have to update. Okay, so rph, and there we go. Okay. Okay, so now you see it's the same here, but once I fetch that value from the tree, I strip the parentheses. Um, just a thing it's nice to do. If we really want to wrap it in parents, then I guess we can handle that somewhere else. But just to have the values as they are, okay? Anyhow, so as you can see, this is the plain pasting, as I like to call it, the plain pasting kind of inlining, right? So we have a single line, and we just paste that. And of course, this is just for demonstration. But suppose we could do, I don't know, we could call some other function on this, say, I don't know, length of join by commas split by I don't know, I'm just making things up here, okay? I don't know, something like this, right? Something crazy like that, right? And so it will just, because it can be expressed as a single line, it will just be expressed as such, even though, like this. Like this could be right, so this could be put into multiple lines, but because it can be expressed as a single one, no problem. We can just have it like that. So this is useful, right? Because it behaves sort of like macro expansion, but not really. Okay, so this is more serious than macro expansion, right? Because with macro expansion, what happens is you get exactly what you wrote, and that is fine for the most basic of users. But once you start getting a little bit funky with it, yeah, it's not so good. So suppose that, and I know this is, in the practical aspect of this, it would be kind of pointless. But suppose I assign something to this just because, right? So let's just hello world, and what do you think will happen if I do this, right? Because here's the thing. Can I seriously just paste that function as it is, assigning something to whatever x is at the time, and then right next to it doing pasting this? Not really, because the result of this I have to assign to x, and I should change the names here so that you are not confused, right? So if I assign to argument here, that assignment should be within the inline part of a function, right? So like or if I add to it, if I concatenate, if I multiply or divide or anything, if I do any kind of modification to the value of this variable we have here, or if I declare a variable myself, right? So my not arg means arg dot something, doesn't matter. If I do this, then if I were to inline it like this, yeah, that doesn't work, right? So what happens is a new scope is created. Okay, so rather than leave the equal sign there, we replace the equal signs with a semicolon, right? So we still have the declaration itself, but for the definition, we take it into a new scope. And what we do is we create a new variable, because now we have to use a variable, right? We have to use that argument not just as a placeholder for whichever value we pass to the function. Now we need whichever value we pass to the function, and we need to assign it to a variable because we are going to be modifying that value. Okay. So yeah, and here, like, so this is kind of pointless, right? First and foremost, we're using a double quoted string for a string that does not require interpolation. My bad. But besides that obvious fault, right? So this doesn't really make much sense in the like in the it does not make much practical sense. There's no real practical application to this little bit I'm doing. I'm just doing this because I know that it would produce the inliner to change the output like this. And it is just to demonstrate, right? What happens in here is that rather than just assign to x the whole line, we declare x, we open up a scope, we make as many variables as we need depending on how many variables we've declared ourselves or how many of our arguments we've modified. And then we just assign to the variable that was declared outside the scope, right? And actually, let me clear so you can see that, okay? So here it is. Let's see if let me see if that thing is in frame, okay? So is it? Okay, okay. Let me just check real quick. Okay. So is it? Yeah, kind of. You can kind of see it. You can kind of see it. So, well, we assign, and then it's basically as if we've had what we had before, right? Effectively, it is the same thing. Now, what if? And this is a fun one. Let's comment out this assignment, and we'll just go back to whatever we had before. If I'm, and actually I'm going to, give me a sec, because now that I realize that my face is in the way of the code, this is kind of unnerving. Let me just find out that preach. So, right here, okay. All right, so now I can just clear. And there you go. Now you can see the whole thing, okay. All right. So if we, another case is if we put the call inside a conditional, right? So this is kind of an interesting one, because it can go two ways, right? So well, no, I haven't. I don't think I've tested this. So I've tested it making the declaration itself inside of here. I have not tested it just doing it like this. Let's see what happens. Okay, so it pastes the thing as it is, which is fine. If we do an assignment, what happens? Aha. Okay, so not implemented yet. All right. I was smelling that that I was overstepping my boundaries there. But if we do declare, right? So this is what I did implement, right? So if we declare this, right? So it will just inline it and assign onto x. But I think we have a problem here. Give me a minute. Oh yeah, right. Because I half implemented that. So suppose we modify the argument, it cannot create a new scope within the if block, right? So what does it do? It uses the same strategy we had before. The interesting thing is that it takes the right. So it takes the function call outside of the conditional, so that it can create it can safely create a scope and assign the value. So kind of crazy, right? But yeah, it's weird to me that that I didn't implement the non non-declarative form, right? So this is not implemented yet. It will give me the backtrace. So kind of interesting that I didn't implement that. But well, we can fix that. So let's see. 544. Okay. So solve BST and right non-decal, non-decal. Okay, so right here. Okay. All right. Well, I'm trying to gather my thoughts here so I can see what am I gonna do about this. Because in this case, is decal is false, which means, and let me just show you this. It's pointer decal, right? And this is just a straight up pattern match, right? So nothing too mysterious about it. So for instance, this right here, it's behind like 90% of the work that the, well, I won't say 90, I'll say 75% of the work that the parser has to make, which is just finding the subroutines and isolating them. Yeah, you can find that with just this expression. And here it's just for detecting that an operator is an assignment operator. Well, in this case, a matching operator, which is not assignment, but you know, because it might, how to say, because it might incur substitution, because it might include substitution within a string, or within a scalar, I should say, I guess, because it might mean substitution, it might include a substitution. I said, well, it is a possible modification of a value, so I want to recognize it as being in the assignment category. And yeah, this section is a mess, right? So this is just patterns that actually I should build programmatically, but I felt like getting things done and thinking about how to do it the hard way later on, right? So this is just done the lazy way. Okay, if you can call this lazy, right? So it's not exactly a solution without any kind of elegance, right? Because suppose here I'm not just repeating the pattern for what is a valid name, I'm just quoting it, so to speak. So what happens with these Bisouescapes, right? So this format, money colon token, token, semicolon, and greater than, you know, angle bracket, closing angle bracket. This is a Pesoescape, all right? So this is a format. I don't know if format is good. A syntax. Okay, can we go with that? Okay, so this is a syntax I completely made up, and wrote a highlighting hook for, right? So because why not? And basically, this is something I use to embed like I want to translate this, I want to turn this into something else, but at a later date, right? So it's interpolation that I choose when to interpolate, okay? So it's a placeholder. It's a placeholder. That is the better way to describe it, right? So basically what it's done is we take those things out, those two things out, those two delimiters, and this will be converted into the value names of the language definition, and names corresponds to anything that is a valid name in Perl, right? So yeah, basically that. Any name you can give a variable or some, well, I suppose for variables there might be different rules. Maybe? I don't remember. Well, yeah, there is different rules for variables, but anything we can call a subroutine, it will match this pattern. And I'm not repeating the pattern, I'm just pasting it over. Um, so yeah, it will be turned into its own compilation, into its own regex compilation, which might be more memory intensive. So we could try and do something about that. Um, uh, it doesn't quite matter. Anyhow, now the thing is, what I'm doing is I have these two modes of detecting an assignment operation, so to speak. So in a declaration, there might be an assignment, not necessarily, and in a definition, the idea is that there must be, right? So in a definition, if you're naming a variable, so there must be an assignment of some kind, right? Or an increment or decrement of some kind. If you're just naming a variable by itself, you're doing nothing. And if you want to have sections of your program where you do nothing, well, that's up to you. But generally speaking, I wouldn't do that, right? So I see no point in doing that, and so I never do that. And so I just assume that if we are not declaring, it's a definition, right? It simple as that. And so that's that. It has to be a mention of a valid variable against an assignment operator. And what is an assignment operator? Again, it is an equals preceded by any of these fine operators or a matching operator, right? So like smart match, I think it's this. I think this is what they call smart match. But anyhow, this is a way you match things together. Okay, but anyhow, it is detected this way, and so if it is declaration, then we know that basically a keyword, one of these three keywords, was mentioned in the same line before the equals. Okay, so preceding the equals, there was one of these, and then a name, and thus we know it is a variable declaration. And so in the case where this happens, the only real difference is that we don't need to paste the keyword, right? So like I know I'm half explaining this thing to you, and another half just talking myself into doing it, right? So but basically there's not much of a difference, to be honest. So I could just do this, I guess. And we don't care about the attributes because there wouldn't be attributes in a definition, right? No, not necessarily. So it is like a bad differentiation to make in here, because obviously a declaration you can declare and define in the same statement, right? So if you had what I consider to be declaration and then an assignment operator, then it's no longer, like technically it's no longer a declaration. Now it is a definition, right? Because you are not just saying this name exists, you're also saying here's a value associated with that name. So that is a definition. But just because I would have to say, we could say this is redefinition, and that would be boring. So I'm just, yeah, it's just a cute way to call the same goddamn thing. So yeah, okay, and this thing is the same. All right, so let's see what happens if we do that. Oh yeah, I do have to update. Okay, and that's a wrap. Okay, but we did not get the value. Okay, so that's a problem. We did not get the my pasted in here, so that's kind of problematic. Huh. Well, but there is no keyword to use, so let me check the tree in here real quick, because we are declaring it as a my. and then assigning to it, and it is it is just stripping that. So I would guess that I'm overwriting the value somewhere around here. Oh, right. Right. Okay. Because I took it out of the line where it was. Okay, let me see. Let me just preach this out real quick. Okay, so I want to see actually at the end of the function. Okay, I want to see what happens in the dang. Okay, this out, but the rest of the tree should be fine. I just go up the hierarchy. Okay. Right, so we have to go one level deeper. That's just this is what happens. Anyhow, okay, so this thing is here. The my is there just fine. So now my question would be, how did I manage to delete that? Right? How did I manage to delete that? Oh no, I didn't. Oh no, I didn't. Okay, all right. Well, I guess what we can do is check for the existence of the variable. We can check for the declared variables within the scope. We can do that. So, and it's not all that difficult, because anything that has been declared within that scope would be it would have to be starting with my, our, or state. And it's guaranteed that if it happens within a single line and not outside of and not inside of a conditional or a loop, right? So inside the suppose you say for my whatever, right? So this one will not be listed as in the way that it will be listed if I say my x whatever. Okay, so this will be listed like this, right, in this kind of nicer format. And so if I just if I just search the branches for those keywords, I can find it no problem. Okay, so let's try that and see what happens. So here's a corner case that I didn't really think about. Okay, give me a second. And the reason why this happens is because the the block, the new scope, let's say, it's inserted like just before the if statement. So I would expect it that it would be like here and not here, right? So right before the if statement, this is what would be there, but it's not what's happening. So actually, wait, before I tried to do a check for declarations, which I actually, okay, so let me just show you that. Okay, let me just show you that because it's fun. But I can totally just say tree branches in, and I mean just showing you that it's trivial to do it. So let's say map arg preach tree branches in, and that will get me every single declaration, right? So there we go. So I can find all the declarations just like that. Okay, so it's not actually problematic, but the question would be, I would have to make like a table out of that and check for the declaration and things like that, just to do it right, and I don't want to. So let's do it the lazy way, okay? So what I'm doing is I'm inserting into the tree, and the way that works is you take an index and just in the place of that you put something else. So basically, if I just preach the tree before and after. Okay, so this is before, and there's nothing above if, and after there's something above if, but it should be like after the semicolon, and for some reason it's like up, which I don't appreciate, to be entirely honest. Makes me wonder. Do I need to id extract this thing? Let's see. So index traversal basically will ensure that the index for every given node is actually correct. And no, that's not the problem. Doesn't seem like it. So the problem is somewhere else. Okay. So probably the insert function itself, because it's the newer function of the family, right? So it's always going to be acting up. Okay. I suppose the problem has to do with this, because rather than assigning the, just assigning the parent and index by hand, I'm trusting the initializer, and the initializer is actually not to be trusted, because it will add the node to the end of the list, and I'm trying to modify the list. Okay, so yeah, that's not going to work. All right, so let's forget about this and try doing it by hand. Okay, let's just say, actually, rather than set the parenting through the initializer, let's just create the nodes parentless, assign them by hand, and then we just, we could id extract, I guess, but we do have to set the parent. So yeah, let's just map this. Okay. And yeah, if you can't tell, I really like map. I really like map. I'm a map freak. Okay, so self leaves. No, actually, I can just right. So arg index equals I plus plus, and arg parent equals self. Okay, that's a wrap. Let's try it. Haha, doesn't work. All right, that's fine. Gold symbol I need to declare that. Okay. Same problem. Still the same problem. Okay. All right, so it was not that. What is it? Give me a sec. It's kind of crazy because I tested this yesterday, and it was fine. Let me try putting in the index by hand. Okay. Or 2. Then it works. Okay, so the function works. Something else is messed up then. something else is missing. And what is missing? I got it now. I got it. Because I don't have to take the index of the grandparent. Right. So the grandparent is root. I want to take the index of if. Holy. Okay. Now I get it. Okay. So actually, I don't need to apply all those changes. The function was fine. Okay. But just one of those things I want to do just to make sure, and just to show you that it was not that same result. Okay, so the function was fine. Okay, I rewrote it. I rewrote it in vain, but yeah, no matter. Okay, so let's just say index, and what we have to do is rather than take the grandparent, we have to take the parent. Simple. Let's just say my parent. And we want to take the parent index. Okay, so that should be enough. And it is. Okay, all right. So, problem solved. All right. It would be, though, nice not to include the thing here. So, we actually can check for that. Like, should we? I think we should, right? Like I just talked about how just putting the doing exactly this thing is kind of meaningless, right? Like it's entirely meaningless. It does nothing. Just pasting the name of the variable there with with no purpose, right? Like it does nothing. It shouldn't be there. So yeah, we should pop that. We should pop that. Well, let's do it like this, because oops, because this is being replaced. This is being replaced through this little thing here, the DST. So if we do not have a destination, I'm sorry, if we have a destination, right? So this is the destination, but we do not have a declaration, and we do not have a direct assignment, then we know we do not have to put it. Okay. All right, so first and foremost, we need to check the assignment itself. And the assignment is, where is it? Okay. Okay, so in this case, it will always be not. And so we only, okay, so nice. So we only need to check for the um, declaration itself. All right, so that's easy. We just check. We say if DST is 0, so it's a declaration. And actually, let's alias that so that it's made clear. Okay, so my isDecl is length of DST0. So if this is a null string, then we know that this thing is not a declaration. Okay, so if not, so actually no, wait. So if is a declaration, then we do what we were doing before. We paste the damn thing. Else, what we do is we just replace the destination with nothing because we have no use for it. Okay, the thing is already declared. We have to do nothing with it. Let's try that. And okay, problem solved. Fixed. Hashtag fixed. So all right, there you go. Quality shit. Oh, I just burnt my finger. That's not nice. Okay. But all right. So that is taken care of. Okay. So let's just keep messing about and see if we can find any bugs, and let's call and let's call it a wrap. Okay. Let's call it a night. I'm sorry. Let's call it a day. I don't know how the expression goes. I've heard it, but I'm not entirely sure how it goes. Okay. So what is the other case that is not implemented yet? I have this function, not implemented yet. Just to put on that message, right? So not implemented yet. This exact message and crash the program, right? It's useful. Okay. So void context. All right. So void context would mean that we are calling the function by itself. No assignment to anything. Okay. So let's just comment this out. Okay, so it says I did not implement void context, but yeah, right, I did not implement it. I did not implement it, or this lone assignment wouldn't be there. Okay. Uh, oh, I know, because this thing only happens. This thing only happens when you're inside a conditional. So, okay, so I should put that. So, inside a conditional, actually inside parents, this would be, but it's what would happen if you had it within a conditional. So basically, if I wrap this in parentheses, it should work fine. No, it doesn't. Okay, so let me preach it out. Okay, preach. Right. Hmm. It's in one line, so it should detect it whole. Well, what's going on here? Oh, it is detecting it whole, isn't it? Oh no, it isn't. Okay, that's fun. That's fun. But kind of crazy because it is picking up on the arguments just fine, no problem. Did I update? Yes. Okay. Kind of crazy. Well, I'm gonna have to see which. Actually, let me comment this out because I like just having that mark in there to go to the top. I'm gonna have to check which path it's taking. Okay. And solve DST. So is it going in here? Here 0. And yes, I know caveman debugging. Bite me. Okay, so here 1. Okay. So it's going through here. Right. So decal and inside parents. There we go. Okay. Right. Right, because it is looking for the destination. Right. So decal. Right. So yeah. No. So inside parents is okay because destination. So destination would be the value onto which the function is. The value where the inlined function return value needs to go to, right? So that's destination, abbreviated DSD. And right, if we have the entire destination, if we match a destination within a single line, then that's fine. If we don't, then we just find it in the tree. Here, it cannot find it in the tree because there is no destination. So actually, what I have to handle is something else. And so this not implemented yet notice is not I don't know what it is. So what I'm gonna do is in this case I am going to take. I guess I'm just going to take the entire block itself and just preach out. Okay. So RD current block, and I'm gonna take the tree of that and preach it out. Okay, and this thing will just quit. Something. I don't know what this is. I don't know if this thing would ever trigger, because if it matches the destination regex, which is taken from here, the pointer assignment, then it has to be either a declaration or definition by how we've described that in here, right? So according to this definition of declaration and definition. So actually, now that I think about it, it should never happen. Yeah, it should never happen. All right. Like the else is just there because I want to make sure that this is, well, tell you what, we'll just throw an error in this case, okay? We throw a full-fledged error in. Non-decal and non-defen DST for inline sub. Yes, okay. Let me just break that down. Oops. Right. And why not? Okay. And the arguments are going to be the block ID. Do I have the block? Yes. So actually I didn't need to fetch it to the parser, but whatever. Okay, so we take the block ID and what else? We set the level to fatal, which will trigger a crash. Okay. So that's that. And if this ever happens, it will crash and it will give us the and it will give us a backtrace like this. Okay, which I don't think this error will ever trigger. I don't think it will ever trigger, but just in case it ever happens, we have a backtrace for it. Right? Better safe than sorry, am I right? Better safe than sorry, okay. So anyhow. What we should do, I guess, is we should check within the moment when we apply the strategy and we do the replacements and whatnot. Actually, what we should do is just check that DST, that the sum of all members of DST just build up to 0, right? Now there is something else. Okay. Right, so I do have to take care of this bit. It is a little bit confusing the way I phrase this. Let me just check a second. Okay, so we do need to take out that equals. Let me just check things real quick. Okay. All right. So red ball itself. Okay. So if we do not have that, oh, I get it. Because the because the equals here. Because the equals here, it's not the equals in this case does not come from the DST fetch. It is within the function itself. So right, and this is a mistake. So what we are doing is we are replacing the return for an assignment, but that is incorrect actually, because we do not know what kind of assignment operation we would need to do to our destination variable. So actually, no good. We should what we should do instead is replace return with two tokens. So one for the name of the destination variable itself, and another one for the assignment operator. In case that we have to do that we have to create a scope, right? If we have to create a scope, then we need to to assign to a variable within a new scope. If we do not create a new scope, if we just straight up inline the function, just copy and paste it, so to speak. In that case, we can just strip the entire return and just place the thing as it is, and we don't have to do any kind of modification. But in the case that we do have to, and yeah, so this I think this thing is here. So let's just go to the bottom, and let me just look for ret. And no, it is not here. Okay, all right. So let me check for ret. Oh, so here it is. Okay, so it was in another place. All right. So this is the same function I showed you, right? So branches in. It will find you every branch within within the entire tree, or within a branch of that tree. It will give you every path that ends with a return, or that contains a return. And we are just replacing that with with a token which goes something like this, right? So ret vol. Okay, maybe you can see it. Right, give me a sec. Oh no, I can't. Okay, so I need to comment out something first, just so you can see that. So here, okay. Oh, holy crap! 2006 246. Oh, because I wrote the damn thing. Oh, it's out of a comment. Okay, there we go. Okay, so let me clear that, and there you can see it. Okay, so what we did is we stripped the return and put this assignment operator there. But actually, what we should do is put another token instead of this. We should put another token and replace that token with the assignment operator. So actually, kind of nice. We're learning something. We're learning something. Okay. Okay, so we've been at it for almost an hour. Okay, good. So this is actually kind of easy. We just create a new kind of token. So let's see, ret, and all we have to do is just create the token itself, and then a regular expression to match it. And this is a file that's mostly dedicated to this kind of bullshit. So yeah, obviously. So let's just call it ASG for assignment. Okay, so yeah, I guess I could just have it so every such token comes from like a prototype, right? So something like this, right? Kind of like this, and then just replace this with whatever. Yes, actually I should do that, but you know, I don't think it's going to change. And anyhow, I don't have that many, so yeah. But yeah, it's a thing I should probably do sometime. Probably after I'm done with this. Okay. But anyhow, now that we have the So it should be this dot this, and this should be AST. Okay. Okay. Oh, I can just right. Let me just do children. Right. Okay. So now. And oh, forgot the semi. Okay. All right. So now we have. Let me just clear that and run it again. So now we have 2 tokens. Okay. And so now we have what we have to do is we now do have to replace the assignment operator in the code when we inline, right? Because we might have a different assignment. We might have no assignment. Basically, yeah. Okay, so let's do that. I think it's apply. Okay, yeah. All right, so it should be this, and what we should do. Well, in this case, it makes no sense because. Oh no 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 no. No, we should still. No. So the format is decal dst. So actually var and assignment op, right? So we know that the third element is going to be the assignment. So let's go for ASC re, and that gives us nothing because we had no assignment operator. Now if we have, say, my x equals this, and that space is optional, by the way. Right, so now we have it like there, like that. What if we try to multiply? Even though, you know, it doesn't actually make sense, but... Okay, so that's not correct. That's not correct. So let's say x equals 1 and x times equals this. Let's see what happens. So x times equals, and yeah, that's not correct. Okay, so we do need to think over this, but yeah, the way we are recognizing the assignment operators is not that well thought out. Actually, if I go into the red string in here. So there is a place in which we are detecting the assignment itself. But I don't think it's right here. Let me check. So if conditional, right? So this is not what we're doing now. Create scope. Right, so it all goes through, yeah. Right. It's interesting because right. Let me go back to that example thing. 1 and x equals whatever this is. Okay. But it should replace it here, but it's placing it here, so that's not exactly right. So this here should be a semicolon. Well, let's print out the tree and see what happens. Okay. Okay. Oh. Oh. Okay. But it's still fetching that operator as it is, right? Okay, so here's right. So here's a problem. Here's one problem. Okay. Right, because it's expecting that this would be a declaration, something like this. Which doesn't make sense, I know, but right. Right, so this should be all a single token. Oh, I know. I know. So I need to go into the lang devs. Oh, I can't write. Okay. Okay, so right, so it cannot take the two operators as a single token because the combination of the two is not registered. This is what I meant when I said I actually need to make it so the detection of these is programmatical, and now it does work because now the assignment operator is a single token, and now it can process it as such, and so now this thing works. And so yeah. So now let's try that. Okay, so we declare first, and then because the other way around it doesn't make sense. You know, you cannot multiply times something that is not initialized, right? So we initialize first, and then we times equals. Okay, so let's see if that works, and it doesn't, which is disappointing. But yeah, I think this has to do with the way that find DST is working, right? So when we cannot find the entire thing within a parenthesized block, and actually now that I think about it, let's try that. Let's see what happens. And in that case, it doesn't really work. In that case, it doesn't really work. Huh. Okay. Okay. So that's curious. Give me a minute. Okay. Oh, because it's expecting that value will be within the branch's parent, which is not right. Actually, what we should do is we should say for my node, and I promise this will make sense in a minute. Okay. So actually, I need to fetch the entire tree. Yes, I need to fetch the entire tree, and we have the entire tree. We can just branch in, and this will give us the first match. So branch in, and just find me cut a fan, right? So basically, this is what it will look like. Okay, so cut fn and cut DST. Okay, so just find me the node that contains this token, and then just replace that token within that node. And so basically, actually I can just do it like this, okay? Find me this node and do the replacement. So what we need to do in here is actually take these values. All right. Let's say let's say DSD and D, and yeah, they might be the same node, but we don't know that. They might be the same node, but we don't know that. So just to make sure. And actually, it's the other way around. All right. So now we just do the same thing, but on the right node, right? Use MD, and now if we run that, ha! Okay, so we didn't find anything, which is curious. Huh. Are you shitting me? Okay, let me think about this for a second. So do I have block even? Yes, I do. Okay, so what's going on is this expression for some reason is returning nothing. It's a little bit crazy, but let me just check something real quick to make sure. So branch in, because if it's trying to find from the start, then it would make sense, but no. So what gives? Like, are you for real? Holy. Are you for real? This is... I like both. They are both non-existent. Huh. Ah. Because this block... Because this block I have here is that of the function I'm inlining. Holy. Okay. Right, because I need to take data from that function from that block, and so that's what I'm using. Okay, so that makes sense. All right, so what we need to do then is fetch from the branch itself. So what we'll have to do is like from tree. Right. So in tree, I'm just gonna make it be the program root. Right. Tree, it should be branch. I think root works for this. Let's see. Okay, so let me actually write a method to get that. Actually, I think I can do branch rain and trees. I think I can get it like this, maybe. Nope. Okay, let me try this. So v2 node pm. So submit, and yeah. So this is not right. Right. Like this is pointless. Root should just be a pointer to the program root, and that's that. Okay. So yeah. All of this is kind of pointless legacy code now that I'm looking at it. This is from a very different conception of the node class. One that I had like at the very beginning when I didn't really understand what I was doing. So yeah, this is outdated. Okay. All right, so let's do this, okay? So let's say that my root is undefined, okay? And we just delete this bullshit. And if not defined parent, then root is undefined, so we have to do nothing. So if defined parent, symbol, then root equals parent, and that is that. Heck, I don't even need to declare root. Because if there is no parent, then parent is undef. Oh, wait. No, I do need to find. Right. Because, right, so parent will be undefined if you're creating a root node, and so effectively your root would be yourself, right? So root equals root, and you know, if root is yourself, then basically you go in here and you just say node root equals self, which doesn't make a whole lot of sense. I'd rather just leave it undefined, and that's that basically. Okay. So what we have to do is just we say that root is parent, and while root we have to go back. Oh well, I can just fetch the root from the parent, but what if a parent does not have root? Yeah, you get it. It's kind of annoying. So while defined root parent, right? So while we are not on a root tree, we keep going up, and so root equals root parent, and that would just make us go up. Okay, and we'll stop when this thing is undefined, meaning that we cannot go up any longer, meaning we are at the root node, and so we've obtained the root itself. So now let's try that. Second in here. So let's just, yeah. This entire thing makes no fucking sense, so let's just branch root. Oh, that is an error log. That is a nice error log, okay. So 77. What do you mean? Oh, semicolon. False alarm. Can't call meta branch in an undefined value at suck my, okay. Control yourself, live. Okay. Well, I suppose I need to adapt the other methods. So, for instance, edxtrav. So edxtrav is just setting the indexes of things, right? So this is fine. But for instance, pluck. Oh no, pluck is just deleting things, isn't it? Yeah, hell yeah, it is. No, I'm thinking of push. Push leaves, right? Oh no! Look at that. I was already handling it. I'm a clairvoyant or some shit. I was already handling it. Okay, so what? So root is undefined, which means I don't know how to do math. Okay, so okay, so let's just like if so root parent else root and shut up. Okay. Well, this is sad. Uh, okay. Tell you what, I'm going to delete this and just make this into a method and be done with it. Okay. Goodbye. Okay. Look for it and get rid of it. Ah, this is an old function. It doesn't matter. I just one. So what was this thing doing? Okay, so it creates a new tree. And it's never used. Yeah, I've already decided I don't care about this. For bookkeeping, I'll just scrap the whole system. It doesn't matter. It's such a small portion of the class that it really doesn't matter. So let's just say root. Okay. So well-defined self-parent root equals self-parent equals actually root of parent. Okay. Okay. There we go. Okay. So while we can go up, we go up. When can we no longer go up, we return the root. Okay. So that should work. Much easier than bookkeeping. Okay. You know, at some point, you just get the value and shut up. Okay. So that halfway worked, but not really. Where is that? So we did get the node itself, right? We did get the node itself. Oh, because I was trying to substitute on the parent. My bad. Okay. So now it should work. And there we go. Right. Now it should work. So now it should work. Yeah. Okay. All right. It's not right though because yeah, it's wrapping it in parentheses and yeah. So this is wrong. So yeah, I would have to tweak this a little, but yeah, we're already over an hour into this video, so yeah, I think yeah, I think this is good enough for now. I need to clean up this code because it's messy. Yeah, it is. It's quite messy. Um, but yeah, like we can handle some of the more basic corner cases, and the more complex ones will have to wait, I guess. Okay. 691. What are you talking about? Oh, right, because there is no destination. Not define is the node, then just do nothing. Wait, I'm sorry. If defined, then do something. It's the other way around, okay? Right, but this, yeah, like that, this is not right. Not at all. Yeah, okay. No. So we do need to tweak this. In this case, though, okay. In this case, it will be fine. All right. So here, right. So here we are calling it in true void context. In the other case, we weren't. Okay. Almost an hour and a half. So I'm going to stop in a second. Just give me like a second. It's all right. Um, we have to do a few things. Um, like there's too many corner cases, so I do have to try and look at them one thing at a time. Uh, there's obviously some possibilities for this whole thing breaking down that I didn't consider at first, but like yeah. What we have to handle is inserting the assignment operators in the right place and all of that, like this point in here. Right? So instead of having this thing out here, what we have to do is take this piece of code and slap it there inside of the code itself. Of the yeah, the code definition itself. So what that would take is recognizing this bit as being the destination, which I think is already happening, and just not. I'm just not doing anything with it. See if I refuse to do this substitution here. Oh no, it is not finding it. Okay, all right. Okay, so it doesn't recognize this bit as being the destination, and so I have to look into how to more accurately do that. I know for a fact that if I put the declaration in there, it will, right? If I put the declaration, it will work. So yeah, because it's dependent on the declaration being there. So actually, it has to do with find destination, which means, right, so is decal when the, right, exactly that. When the parent of the branch is one of these keywords. And right, and else I'm just not, it's just not implemented, right? Okay, so, well, if this is not the case, then it just would be the name, okay? So is decal is null string, and dst is the branch parent value. Right, and so asg would be, holy fucking shit, I hate that shortcut. Because I don't even know what that shortcut is. I always press it by accident. Ugh. Okay. So let's say that this thing, actually I can say leaf value. Yes. Leaf value 0. So the first leaf in that subtree, so the first child would be the assignment operator itself. So let's assign that to ASG and let's see what happens. And there we go. Kind of, I think, maybe. Let's remove the decoration. Let's see what happens. Nope. Well, half and a half. Okay, so see. Now it can do the replacement in here, but we still need to handle this this case, right? So what we should do actually is we should pop. Okay. So what do I mean by pop? I can close this now. I can close this as well. And yeah, okay. So what we have to do is pop this to actually pluck. Is the more is the name of the thing, but we do have to take these things out. Well, I would just take like the first leaf and be done with it, and then the DST itself. What can we do with that? I don't know. I'll think about this in a second. Okay, give me leaves 0, so that's that. And with that being plucked, actually I'm going to say parent just because I like to be verbose. Parent value and parent leaves and parent leaves and parent block and parent value. And so now we do parent, and yeah, this is like the tedious part of watching me code. Just deal with it. Okay. All right. So there we go. If we pluck that and we change the value as we are doing here, then it should behave roughly in the same way. Let's check it out. Aha! So pa, where did I left pa? Where? 373. Oh, yeah. Okay, so I'm slow at that. Okay. All right. Okay. And so that thing is blocked. And now we can find everything. All right. Okay. So that's a commit. And that's a wrap. Okay. So let's recap. Let's just find the original code. Okay. So we can declare a variable, give it a value, and then just multiply that variable by the return of our inline subroutine, and that's a wrap. Okay, so we do have to, I'll fix this later on, I suppose. If we do not have a declaration, we have to strip out that needless mention of the variable. So actually, I think I can do that like right now. Right, so this thing I did right here, basically. So it is decal, and the way to know if it is decal, I suppose it is the same for all branches of execution, so I will just put it in there. In this case, then we just use the okay. Okay, but I do have to code like this, not like this. Okay. All right. Okay, good. Let's see about that. And there we go. Okay, so done. Well, just to keep that recap, we can modify an already existing variable. We can take that variable and shove it inside of an inline subroutine and modify the value according to whichever assignment operator we choose to utilize. It will just the same effect will be achieved, but within a separate scope. And this obviously will affect the variable at this scope, right? Because it is not being redeclared. So pretty cool. What else? I suppose I should look into renaming all of the arguments within the function. But I mean, it is something I'm already doing, right? So inline defend argument, right? So I'm already creating a new name for the argument whenever I have to, minimally use the argument. So yeah, just one of those things. So now we can also have this work inside of an if, right? So we clear it outside and then use it inside. The entire expansion happens, and it's clear. So we declare outside, the entire expansion happens outside, and ooh, we are not replacing this bit. So that's nasty. That's nasty of me. Okay, give me a sec. Okay, so up here. Okay, good. All right, so that's done. Okay, so little slip up in my part, but anyhow. So in the original, and oh, that is a problem. Oh my god, the corner cases never end. Oh, all right, all right. Well, uh, just ignore this bug for a minute. We can take the call outside of the loop and just expand it outside. In the case that we need to do that, if we do not need to do that, it's just something like this, then we can just put it inside the if and call that a day. So, yeah, that's that, and that's that. Have a good one. Bye. That's it from me. Bye.